Welcome to our deep dive into the solid principles, a cornerstone of object-oriented software engineering. Solid isn't just about writing clean code in isolation. It's a set of corrective mechanisms that help engineers address structural problems as they arise. Each principle answers a critical question. What kind of change is making this code fragile? Throughout this video, we'll explore how Solid acts as an engineering decision framework, guiding developers to detect violations and fix them, rather than blindly applying rules. Let's begin by understanding the system-level view of Solid and why it's essential for robust software design. Before diving into each principle, it's crucial to grasp the system-level perspective of Solid. Rather than applying Solid principles as a checklist, engineers use them to detect violations in their codebase. When structural issues emerge, Solid provides a framework for corrective action. This approach ensures that the principles are not just theoretical, but practical tools for maintaining code quality and adaptability. By focusing on the system as a whole, developers can anticipate potential fragility and address it proactively, leading to more resilient and scalable software. Applying Solid is not about following rules blindly. Instead, developers detect violations, situations where the code becomes fragile due to certain types of changes. These violations often surface when multiple stakeholders or concerns intersect within a module. By identifying these triggers, engineers can apply the appropriate Solid principle to restore stability and maintainability. This proactive detection is what sets Solid apart as an engineering decision framework, making it a dynamic tool for software evolution. Single Responsibility Principle, SRP, states that a module should have one reason to change. This reason is mapped to a stakeholder or concern. For example, if the same class is modified by the business team for logic changes, the DB team for schema changes, or DevOps for logging and configuration, SRP is violated. By ensuring each module has a single responsibility, engineers reduce the risk of unintended consequences and make the code easier to maintain and evolve. Trigger conditions for SRP violations include scenarios where the same class is modified by different teams for unrelated reasons. Business logic changes, database schema updates, and DevOps logging or configuration adjustments are typical examples. When these changes overlap, the module becomes fragile and difficult to maintain. Recognizing these triggers helps engineers refactor their code, assigning clear responsibilities to each module and preventing future instability. Solid principles are most effective when applied in response to real-world problems. Rather than enforcing them as rigid rules, engineers use Solid to guide their decisions when structural issues arise. This practical approach ensures that the principles remain relevant and adaptable, supporting the ongoing evolution of complex systems. By integrating Solid into their workflow, developers can maintain high standards of code quality and resilience. Mapping responsibilities to stakeholders is a key aspect of SRP. Each module should serve a distinct concern, whether it's business logic, database management, or operational configuration. By clearly defining these boundaries, engineers prevent overlap and reduce the risk of conflicting changes. This mapping not only improves maintainability, but also streamlines collaboration across teams, ensuring that each stakeholder's needs are addressed efficiently. Business logic changes are a common trigger for SRP violations. When the business team modifies a class to update functionality, it can inadvertently affect other concerns, such as database schema or operational logging. By isolating business logic into its own module, engineers ensure that changes are contained and do not disrupt unrelated parts of the system. This isolation is fundamental to maintaining a stable and scalable codebase. Database schema updates often require changes to classes that interact with the database. If these classes also handle business logic or operational concerns, SRP is violated. By separating database-related responsibilities into dedicated modules, engineers can update schemas without affecting other parts of the system. This separation simplifies maintenance and reduces the risk of unintended side effects. Operational concerns, such as logging and configuration, are often managed by DevOps teams. When these concerns are mixed with business logic or database management in the same module, SRP violations occur. By assigning operational responsibilities to separate modules, engineers ensure that changes in logging or configuration do not impact other areas. This modular approach enhances flexibility and supports efficient system operations. Integrating solid principles into the development workflow is essential for long-term code quality. By regularly reviewing modules for potential violations, engineers can proactively address fragility and maintain a robust architecture. This integration ensures that Solid remains a living framework, evolving alongside the system and supporting continuous improvement. CodeFarm Java ecosystem focuses on Java engineering at scale, including Spring Boot, distributed systems, event-driven architecture, observability, and cloud-native backend design. By applying solid principles, developers in this ecosystem can manage complexity and ensure that their systems remain adaptable and resilient. Case studies and tutorials highlight how Solid supports best practices in real-world scenarios. Distributed systems present unique challenges for software design. Solid principles help engineers manage these challenges by promoting modularity and clear responsibilities. By applying SRP and other solid principles, developers can build distributed architectures that are easier to maintain, scale, and troubleshoot, ensuring reliable performance across the ecosystem. Event-driven architecture relies on modular components that respond to specific triggers. Solid principles, especially SRP, ensure that each component has a clear responsibility and reacts only to relevant events. This clarity supports scalability and simplifies debugging, making event-driven systems more robust and easier to evolve. Observability and cloud-native backend design require systems to be transparent and adaptable. Solid principles help engineers build modules that are easy to monitor and modify, supporting rapid deployment and efficient scaling. By adhering to Solid, developers can ensure that their cloud-native systems remain resilient and responsive to changing demands. CodeFarm Java ecosystem invites developers to contribute tutorials, case studies, and deep technical writing. By sharing experiences and best practices, the community helps others understand how solid principles can be applied to solve real-world problems. This collaborative approach fosters innovation and continuous learning, strengthening the ecosystem as a whole. Arvind Kumar, a staff engineer specializing in system design, microservices, Java, Spring Boot, Kafka, DBs, AWS, and GenAI, teaches concepts through stories and characters. His approach emphasizes the practical application of solid principles, helping engineers understand how to make effective decisions in complex environments. By learning from industry experts, developers can enhance their skills and build more resilient systems. Solid principles serve as an engineering decision framework, guiding developers to make informed choices when structural problems arise. By focusing on corrective mechanisms rather than rigid rules, engineers can adapt their approach to the unique challenges of each project. This flexibility is key to maintaining code quality and supporting ongoing innovation. Object-oriented systems can become fragile when modules are not properly structured. Solid principles help engineers identify and address these weaknesses, ensuring that the codebase remains stable and adaptable. By understanding the triggers for fragility, developers can apply Solid to prevent cascading failures and maintain system integrity. Continuous improvement is at the heart of Solid principles. By regularly reviewing and refactoring code, engineers can address emerging issues and maintain high standards of quality. This ongoing process ensures that the system evolves in response to changing requirements, supporting long-term success and sustainability. Effective collaboration across teams is essential for applying Solid principles. By clearly defining responsibilities and boundaries, engineers can prevent conflicts and ensure that each stakeholder's needs are met. This collaborative approach supports efficient development and helps maintain a stable, scalable system. Maintaining code quality is a continuous challenge in software engineering. Solid principles provide a framework for addressing structural issues and ensuring that the codebase remains clean and maintainable. By integrating Solid into their workflow, developers can uphold high standards and support the ongoing evolution of their systems. Software systems must adapt to changing requirements and environments. Solid principles help engineers build flexible architectures that can evolve without introducing fragility. By anticipating potential changes and structuring modules accordingly, developers ensure that their systems remain resilient and responsive. Tutorials and deep technical writing play a vital role in spreading best practices and Solid principles. By sharing detailed examples and case studies, experienced engineers help others understand how to apply Solid in real-world scenarios. This knowledge transfer supports continuous learning and strengthens the engineering community. Industry leaders, such as staff engineers and directors, play a crucial role in shaping engineering practices. Their insights and experiences guide the application of Solid principles, helping teams make informed decisions and build robust systems. By learning from these leaders, developers can enhance their skills and contribute to the success of their projects. Applying Solid principles can help developers grow their careers or build new ones. By mastering these concepts and demonstrating their ability to maintain high-quality code, engineers position themselves as valuable contributors to any team. This expertise supports career advancement and opens new opportunities in the software industry. Expertise in the Java ecosystem, including Spring Boot, microservices, and distributed systems, is enhanced by applying Solid principles. By structuring code according to Solid, engineers can manage complexity and ensure that their systems remain scalable and maintainable. This expertise is highly valued in the industry and supports ongoing innovation. Microservices architectures benefit greatly from Solid principles. By ensuring that each service has a single responsibility and clear boundaries, engineers can build systems that are easy to scale and maintain. Solid supports modularity and independence, making microservices architectures more robust and adaptable. Teaching engineering concepts through stories and characters makes Solid principles more accessible and engaging. By illustrating real-world scenarios and challenges, educators help developers understand how to apply Solid in practice. This storytelling approach supports deeper learning and encourages creative problem solving. In summary, solid principles provide a powerful framework for engineering decisions in object-oriented systems. By detecting violations and applying corrective mechanisms, developers maintain code quality and adaptability. Whether you're working in the Java ecosystem or exploring new technologies, integrating Solid into your workflow supports continuous improvement and long-term success. Stay tuned for more tutorials and case studies to deepen your understanding and enhance your engineering skills.